All right. Hey, humans, Miss Jeffords here. Gonna record a hopefully quick lecture for you about standard 1.1.3, which is map projections and distortions. Guys, maps, we are trying to take something round that is a sphere and we're trying to flatten it out and put it on paper. And so, of course, there's no perfect way to do that, and it always ends up distorted in some way, shape, or form. So, just a review of this key term, a map projection is simply trying to get the curved surface of the earth onto a flat surface like a map. I love camping and hiking, and I often use maps to obviously locate where we are. And I mean, a globe isn't going to really fit very well in my back pocket, but a flat map does. You guys already know maps can be very selective in what they portray, and therefore, depending on the projection of the map being used, it can be used for different purposes. So this is a video. You guys definitely need to take a few minutes and watch it. It's pretty awesome. Called "Why All Maps Are Wrong." And again, the bottom line of that is they're wrong in the sense that they're all going to have some level of distortion due to that taking that 3D sphere and trying to flatten it. Okay, so again, here we go. This is what we're trying to work with. And so if you've ever there's a lesson we've done before. Take an orange and peel it and try to keep the peel as intact as possible, and then flatten the peel out and try to see if it, how it transfers, if you will. So especially this is a really interesting satellite image. The Earth isn't this perfectly round sphere as I think we assumed it is. And how do you take that information and put it onto a flat surface? If you guys notice on this map here, there is some major distortions, namely Greenland and Antarctica are humongo, and that is actually not how they are, but the way that the projection distorts that immaterial is obviously very evident. All right, so map projections are sad, super sad, 2D sad, because they distort these four things: the shape of land masses, the area of the landmass. So again, that kind of goes with the shape, but it's also like the size, the relative size of it, the distance between certain land masses, and then finally directionality. Remember, we're dealing with a sphere that is round, and there's the directions are infinite. And so depending on the map projection would obviously impact that. All right, so your crash course on these. So the Mercator map, this is one of the kind of still most it's you see this projection all over. 1569, it's pretty impressive. It was made at that time, and you guys can see here we have advantages. The direction of the way that the land masses are aligned is accurate. The shape of the land masses is accurate. This is used for navigation purposes, and if you can see here, one of the big reasons is all of the latitude and longitude intersect at 90-degree angles. And think about it, especially 1569, if you were a navigator on a ship, chances are you were coming from Europe and you were just kind of going a straight line west. And so this type of map that kind of lays out this grid pattern would have been very helpful for a navigator just literally trying to go sideways. Okay, this preserves right angles of latitude and longitude. And again, we know lat and long, those are human created imprint on maps to help us really understand the coordinates of locations around the world. All right, so what are the disadvantages? Areas distorted near the poles. So again, we have Houston, we have a problem here because these lines are infinitely going off the sides of the map, and on a sphere, obviously, that's not what happens. Also, the increase of the size of high latitude areas. So remember map 101, if we have our equator, this red line going down the middle, then what happens is your latitude lines, they form a pattern from the equator. Mid-latitude temperatures like in North America are going to be the same on the other side of the equator, South America, go on. That's why with the cold areas are going to be the top and bottom of the globe. That's why here in Colorado, for example, so if Colorado's roughly here, if I was to go equidistant down from the equator, these countries here are going to have a very similar climate and latitude of Colorado because it just repeats on other sides of the equator. Okay, as you can see, the further away from the equator and closer to the poles you get, you see a major warping distortion of those sizes. All right, the Peters equal area projection. So right now you can obviously see some similarities to Mercator. Obviously, we still preserve those right angle, latitude, and longitude, but you can see some major distortion, especially toward the poles. So again, you do get this kind of weird squished north and then southern poles here. So advantages here: areas of land masses are accurate. So this shows you kind of more accurate size in relation to Mercator. And so again, you can see that Antarctica is not this humongo white thing at the bottom of the map, but in fact, it's it's not as big. Repositions many countries to their rightful size. Disadvantages: shapes are inaccurate. So again, these shapes are smooshed. They're kind of, again, they look like you, instead of diagonally stretched an image in your slideshow, it looks like you did like the side to side, and it kind of made it weird. And then you can see what happens around the equator. The gap it's vertically stretched, so you do again see that distortion. Okay, so here's interesting. This is an overlay of the two. So the blue is going to be Mercator, that first one we talked about, and then this is the Peters projection on top of it. So you can see, I mean, there's some pretty big differences here. So obviously, if you were, a navigator and you were like going back and forth between these two maps, I mean, you're going to end up in the Bermuda Triangle is really what's happening down here, because things are completely out of whack. All right, here's another really interesting one. So again, this is your Mercator versus Peters. You can see if we overlay the Mercator projection of Africa with Greenland over it versus this, a Peters projection is more of the true, like, accurate size. So you can see Africa still retains it's a big continent, and then Greenland really in realistic is really not that big comparatively. All right, another one we see is the Robinson projection. So you can see this one as attempting to maintain the spherical shape of the globe, but obviously we're still trying to flatten this, right? We're still trying to put it on a map. So advantages: there are no major distortions. So if you were to hold this like side by side to a globe, you would actually see that this looks pretty, they mirror each other. The purpose of this map is simply a happy medium between Mercator and Peters, and then bringing it to more of that spherical shape. So again, this is the go-between map for both. Disadvantages: all aspects are slightly distorted. So again, if we go back to our SAD acronym, the shape, area, distance, and oh my gosh, the other D, those are going to be distorted here as well. All right, now things are going to get real weird here in a minute. So these are some other projections, and then obviously some evident distortions. So we have over here, this is the conic, whatever you want to say, projection. And again, if we're looking at this 3D, it actually looks like if you were looking at like the bottom of an ice cream cone, and then it's like going out. So this little point where everything kind of comes together at that's the North Pole point, and then you can see how things go out from there. This one is azimuthal. So obviously this is it uses azimuths in like geometry to make that projection. And then you have this funky thing over here, which is Fuller. And this is really more for like, this is kind of like one of those puzzles. Like if you were to cut it out on paper and then you try to like shape it back into original shape. If we were to cut this out and try to shape it, it would end up back in some like a spherical-ish shape. All right, so who cares? What is the point of any of this? What even is any of this? All maps are selective and they distort the Earth. I mean, that's like the bottom line. So when we talk about like bias in the media, we talk about, like bias in historical documents, there's bias in maps. And so you have to understand that the map you're looking at is already lying to you. It's not telling you the truth. And if you're aware of where the distortions are, then hopefully you're still able to, use it for the purpose you need it. So I like this graphic. It's kind of cool. So it takes this dude's head, which is already kind of creepy, and it shows what happens to that same image on all these different projections. And so again, you can see the same data, but how it can look incredibly different. So that's kind of the big, takeaway with maps and map distortions, that just know that there's something wrong with it. So most accurate would be globe, but obviously globes are not super user friendly in terms of like portability and, on your phone. Like if I was to like Google Map something, it's not bringing up a globe for me to look at. It's going to be bringing up like a flattened projection. All right, guys, that's what I've got for you today. Keep learning, stay curious, and I will see you guys later. Bye.